privileged to introduce and welcome Richard Cohn to our center and to our keynote series. So allow me also to start with a personal note here. Richard Cohn was my PhD supervisor at Chicago, and I believe I was his last or next to last student over there before he moved to Yale. Anyway, I consider it a tremendous privilege to have studied with you, and I have learned a lot from you and continue to learn throughout all these years. So Richard Cohn is currently Battle Professor of Theory of Music at Yale. He is one of the rare individuals that you can say has been shaping and exerting a significant influence in the way the entire field of music theory and related disciplines have evolved in the past 35 years. Richard Cohn received his PhD from the Eastman School of Music under the supervision of Bob Morris. And in his early career, he wrote a number of key articles on Schenkerian theory and aspects of pitch space in the music of Bartók that indeed questioned the dogmatic ways in which these subjects were treated back then. He taught at the University of Chicago from '85 for 20 years, and where he later served as department chair. In the 90s, he published a series of influential articles in two separate subfields of music conceptualization, and highlight in particular the articles on Steve Reich's space shift in music and on late romantic triadic progressions, both of which won the Outstanding Publication Award of the Society for Music Theory. The later article in particular is often considered as having inaugurated a large and vigorous subfield in music studies known as neo-Riemannian theory. So in 2004, he founded the Oxford Studies in Music Theory, which he edited for Oxford University Press for 10 years, and is currently executive editor of the Journal of Music Theory. He has also been significantly involved in a number of professional societies, such as the Society for Music Theory, Analytical Approaches to World Music, and the Society for Mathematics and Computation in Music. So his research on 19th century harmony culminated in the celebrated book Audacious Euphony, Chromaticism and the Triad Second Nature, published by Oxford University Press. And more recently, he co-edited a volume on David Lewin's analytical writings, who was perhaps the greatest music theorist in the 20th century. In the past decade or so, he has been making strides on aspects of musical time and temporality, and he's currently working on a monograph tentatively entitled An Analytical Model of Musical Meter, which works a general model with applications for European, African, and African diasporic music. So today he's going to talk about the tensions or disjunctions, as we say, between historical conceptualizations of rhythm and meter, with its roots on poetic meter, and our musical experience and perception of music, and scientific knowledge about neurocognitive responses to music. So today's talk is entitled Asian Theories of Poetic Meter Distort Modern Conceptions of Musical Meter. Please join me in welcoming Richard Cohn.
It is such a privilege to be here in Portugal and at the University of Coimbra, and to have my old friend and now colleague Jose, and to see how beautifully he is doing, what sort of impact he's having on the Portuguese Music Academy, and it seems more interdisciplinarily. I should say that as editor of Journal of Music Theory, I'm proud now to be publishing his very recent article on the music of Luzoslavsky. It will be a very important piece of writing for scholars of Luzoslavsky and 20th century music. I also want to thank the staff for accordingly setting me up to give this presentation and struggling with technology. Thank you. Third thing I want to say for starters is thank you for allowing me to speak to you in English. I understand, I mean, it's always amazing to me when I'm able to talk in my own language and you are able to receive what I say, even though this is not your first language. So I do appreciate that. So Jose mentioned that, I guess I'm going to start by saying a word of how I got to this interdisciplinary topic from the point of view of a topic which is very firmly seated in my home field of music theory. So I've been working on what I call an analytical model of metric theory, musical meter. And at a certain point, I realized that, well, the way that I was conceiving of musical meter was completely different from the way that most musicians speak about musical meter. And so I wondered, well, where does it come from, this way of speaking, which seems to have some things in it which are strange from the point of view of musical experience and from the point of view of what we know scientifically about musical meter. And that brought me to the idea of why are people taught the way that they're taught about musical meter. And so I started thinking about how musical meter is offered in textbooks. And I realized that that also had very little to do, to my mind, with musical experience and scientific knowledge. And this sent me on a historical journey, because when everybody is talking in the same way, that way comes from somewhere. And usually there's a reason why ideas come down to us the way they do through history. So that's kind of the basis of my talk, and it's making me interdisciplinary in the sense that I will be talking about some about poetic meter, some about classical poetic meter, and I'll be talking also about the genealogy of ideas as they occur in music. So I'll start by reading from my text now, and I should say, for reasons of time, what would be a good?
About 15 minutes,
Oh,
45, 50.
Good, I can do that. Yeah. Okay. So our capacity for music is born into us. And this is true at the individual level. We know that infants respond to perturbations. They show alarm when some musical pattern is disrupted. And it's also true at the aggregate level. We know that all human societies have music in some form. So we have a general capacity for music, and this is analyzable into several specific capacities. And two of the most significant of those, oh, by the way, if I'm going to advance the slides, what do I want to do? I probably want to have the keyboard on me, right?
Okay. But if you want, I can do that.
Oh,
Where are they? Probably not here. I can see.
okay, these slides are not, they're sort of supportive of my text, but not.
Probably.
Oh, there we go, okay.
Sim. Ok, isso mesmo. Aqui, não?
Não, zoom.
Ok. Yeah.
Compartilhar a tela. Isso. Assim toda a gente vê. É isso. E agora também convém ser ecrã inteiro, senão vai-se ver os que estão em baixo também.
E é este aqui, não?
Exatamente, isso mesmo. Right.
Oh.
Good. Yes, exactly. Now, is there a way that I can control the mouse? Do I need to move a little closer? I think I'll do. No, perfect. Is there right mouse, left
I think
mouse?
you go down like this.
Oh, with the red wheel.
Yeah, I think so.
I think I can adjust to that. Okay, so two of our most significant general capacity, or specific capacities that feed the general capacity are our capacity for tonality and for meter. These terms are usually applied to particular pieces of music. We say this piece is in G major, or this piece is in triple meter, but underlying all of that, there's good reason to situate those properties primarily in us, in our minds. We have inborn regulative systems that spontaneously find patterns and assign meanings to sonic input. And this all happens beneath our horizon of conscious thought in the general case. So what our tonal capacities regulate are pitched sounds, and what our metric capacities regulate is our interpretation of patterns of sound in time. The total set of pitch and time relations is usually sufficient to give a composition its identity. And so a two-dimensional grid is sufficient to represent music. Anybody know what piece that is? You'll recognize in a minute. The grid, of course, is stylized in certain ways. So we have pitch going down to the bottom to top.
Crater shack, no?
Exactly.
Yeah.
Okay, so there it is, right? Looks sort of got the same basic shape, right? Now, since music is primarily co-defined by variation in these two dimensions, one might guess that music researchers would kind of divide their time into half and spend half their time on theory of tonality and half their time on theory of meter, but this has been far from the case historically. The history of music theory is a continuous series of writings from the 14th century about tuning systems, scales, chords, voice leading, counterpoint, all of which are aspects of pitch theory. And if we go back deeper into the history where we have more sporadic documentation, we find treatises, or let's just say documentary traces of tuning systems and scales from ancient Mesopotamia, from ancient China, so 400 BC, and from Greece around the same time. It's pretty much all about pitch and not about musical time. For musical time, there's no continuous series of treatments. It comes up every now and again, and usually theorists become interested in musical time when the notational system is all of a sudden destabilized and is being replaced by some new notational system. So most importantly, in the 14th century, when the system of mensural notation arose, and then again in the 17th and 18th century, when the system of bar lines and meter signatures that we now are familiar with. Now, there is one exception, and that is the last 50 years. Our notational system has been pretty stable, but there's been an exceptional amount of research in musical time, in my field of music theory and analysis, and in music psychology, and more recently in neuroscience. And this is fueled not by notational change, but by technological change. We now have the capacity, as of about 100 some years ago, to freeze the musical object for study. We can record it. More recently, we have the capacity to inspect it at a very microtemporally detailed grain, right? So we can see what's happening within these 0.05 seconds. We also have capacity to study musical behaviors in much more detail, closer detail, because of technology. And most recently, we have the capacity to read how fast our blood is flowing through our brains to a certain limited degree, and where our blood flow happens in what part of our brain in response to what musical input. So research is kind of caught up. Textbooks, not at all. Textbooks in music theory are almost all about pitch. Oops. So here's a table of contents from a recent North American textbook, and you'll just have to take my word for it. This is entirely typical. There's one chapter. And if you read that chapter, what you will learn is mostly about notation. So 2 quarter notes make a half note. There's really not much in the way of what we would call, from a scientific modeling point of view. What you do get, if it comes under the heading of theory, is a definition of what meter is, and a very rough system for classifying meters. And so I'll begin by critiquing the definition and the system of classification. Now, the definitions and the system of classification are identical, well, virtually identical from one textbook to the next. So here's one. Oops. Let's see, did I do so? Oh, there we go. Is there any way I can block that? Is there something I can do with the mouse?
I think you can do this one.
Perfect.
Yeah.
Oh, thank you.
And I think you can click the mouse also to
Oh, to advance it.
advance it.
Oh, okay.
I think you can do that, right?
So this is from Stephen Leitz's book, very popular book in conservatories and universities in the US. Beats are grouped into a regular repeating pattern of strong and weak. That's the meter. And so we have a few different things. So beats are the main objects or elements of meter. They are grouped. They form patterns. And the patterns are distinguished by some relationship of strong and weak beats. Okay. And here are three other definitions, and you'll see that the same words with insignificant variations occur. Strong and weak sometimes is referred to as stressed and unstressed, unaccented and unaccented, but basically they're saying the same thing. Now, one might take this as a triumph. We've decided what meter is, it's stable, we're good scientists, everything's good. But I don't think that's the case. I take this as a sign of essentially indifference. As for classification, we all learn, at least in my culture, but I think maybe in yours also, that there are three kinds of meter. Music is in 2, it's in 3, or it's in 4. And that those come in 2 varieties. There's a simple 2, 3, and 4, and then there's what's called a compound 2, 3, and 4, which has larger numbers. Well, I guess I don't need all this. Yeah, get rid of that. Oh, okay. So in the definition, I think I'll go back to the definition. Yeah. In the definition, none of the core terms are defined. What is a beat? What is an accent? What does it mean to group? And for the most part, they're not really capable of definition. When you try to define them, illogic starts to pop in. The terms are used in polysemic and ambiguous ways, and the definition makes some claims that are just false, or that encourage misleading inferences. As for the classification system, what it classifies is not meter in the sense of our bodily response to incoming sonic input, but categories of representation. There are 6 kinds of meter signatures, right? And these are, of course, notational conventions, but they represent unreliably a subset of the pulses and relations that we intuit when we encounter music. So it would be as if we were to claim that this human language were composed of the following 26 sounds and try to build up a theory of phonology with that as our inventory of basic sounds. That would be an error. At least phonologists would say so. The influence of the textbook definition and classification system is not limited to the classroom. It influences how musicians talk to each other. And since scientists study music, it influences sometimes at least the assumptions that scientists make when they make hypotheses and interpret data. So in part 1 of this talk, I'm going to identify 7 different ways that the standard textbook sketch of musical meter claims or implies properties that are disjunct from experience or scientific knowledge or both. Having sketched these problems, I'm going to ask, where did the definition come from? Whose interests did it serve? And this will launch my historical origin, which will, historical search for my search for historical origins, which will take me back to ancient Greece 2,500 years ago. At the beginning of the process that I'm going to document is classical poetic theory, first in ancient Greece and then Rome. And it's going to end up here with 21st century music theory as it's taught in textbooks. And the interim stages are, first of all, 18th century poetic theory as it interpreted Greek theory. And then 18th century music theory, I don't know why that dimmed down, but that says 18th century music theory at about the same time. So the middle process is where I'm going to really be focusing. What happens in the 18th century that moves poetic theory or maps poetic theory onto an incipient theory of musical meter. So essentially, we're talking about the time from around the Lutheran Reformation to around the French Revolution. First thing that happened was that the theory of classical poetic meter was granted universal value, and it was adopted as a model for emulation. It was taught in the Reformation educational system curriculum to school, I think only schoolboys probably, in Northern Europe. And it was applied to modern languages, even those designed for ancient languages. During that same period, a new theory of musical meter arose, which, and I'll talk about the motivations for that change in meter shortly, but the theory itself served as a classicizing site for emulation. It was granted universal value. This is my hypothesis anyway. It's now taught in the modern conservatory and applied to today's music. Okay? So you can see there's a kind of parallelism in the transmission from a classicizing ancient era. You might ask, well, why didn't the 18th century musicians go back to the music of ancient Greece if they were looking for classical models? But unfortunately, music doesn't transmit like poetry does, unless you have a system of notation. We don't know anything of much. We don't know much of anything at all about what ancient Greek music sounded like. So now we have our classical music, but it's from the 18th century. Anybody who's ever taken a music theory course will recognize that even though you're not studying meter, you're studying harmony and tonality. Almost all of the examples are from the 18th century. So here is a list. I mean, this is kind of dim, but I'll just say there's a long list of Bach, about that first column. Beethoven is a column and a half. Handel gets a little bit. Haydn gets pretty much a full column. Mozart gets pretty much a full column. Right, okay. And this is most of the list of examples. Very 18th century oriented. So I said this is a popular textbook. The music that is writing about is not popular. At each stage of transmission, the source possesses high cultural prestige, authority. So that creates incentives to overmap the properties of the source onto the target. And as a result, as I will document, distortions were introduced into our conception of music. So 5 parts to my talk. Think of it, yeah, okay. First, I present a standard textbook definition. There we go. Standard textbook definition and classification system for meter, and identify some problems. Second, I show how the system is related to 18th century theories of meter. Then I go back to ancient Greece and show how that is appropriated or transmitted into 18th century poetic theory. And all of that's really just a prelude for what I'm going to really want to study, which is this middle leg. So problems with standard textbook theory. So here's the definition again. So what is a beat? Textbooks leave this implicit. There's one property that everybody assumes, the textbooks don't even need to say it, which is that a beat is some set of something which is evenly distributed in time, right? So a beat involves that. Isochrony is another word one would use for that. But what sort of element is distributed isochronously? A first guess might be that the beat is an acoustic sound. There is a series of sounds and they are distributed isochronously. This is consistent with the idea that beats are strong and weak. Strength and weakness are attributes of substances, right? And sound is a substance. One could imagine a sound being strong and weak. But it can't be the case that beats are actually sounds, because what if we do that? Now, those are meant to be rests. It didn't transmit. Where Q is, there's meant to be a rest, and so there are still beats in the right. And so there are lots of silences in those sounds, but they're all beats. The beats include the sounds and the silences. So what is a beat then? It's not necessarily a sound, it's a temporal address where a sound might or might not occur, where we expect a sound but don't always receive it. Okay, so what then is the temporal address? Is it a span of time with extension, or is it just a single point in time without extension? Now we say that the quarter note gets the beat, and the quarter note fills up a certain span of time, and that suggests that the beat is a span of time. And we also, the definition says that the beats are grouped. And grouping is something that happens with spans. It's much harder to think of how points are grouped together because, right, they're isolated from each other. Yet our experience of beats is more point-like than span-like. We keep, I think I have a slide for this. Yeah, okay, this is the next one. So we keep a beat with our fingers and our feet and our necks and our tongue. And like a drum beat, each of those sounds is focused, or each of the thoughts of those sounds is focused on a particular point in time. Neuroscientists, Large and Snyder, write that a beat is traced in neural readings by invisible neural oscillations, which are bursts of action potentials, each of which is followed by a period of quiescence or quiet before the next burst occurs. Okay, so we have three problems. Implicitly, a beat has acoustic substance, as isochrenously presented sounds. The beats group together to form measures, but it's not clear how they do that. And implicitly, the beats are spans with a measurable duration. Like I say, the textbooks never actually say so, but the language that they use around the description of meter implies this. Here's a fourth problem. The definition applies that there's only one series of beats, and thus only one level of patterned isochrony. Yet when we listen to music, we experience isochronous patterns at various speeds all at the same time. When we dance, our torso is dancing maybe to the half note, and our shoulders are dancing to the quarter note, and our wrists are dancing to the eighth note. So we're keeping all of those times. So the questions are, well, which one is the beat? We could ask the composer. The composer writes a meter signature and says the quarter note gets the beat. But the fact is that most of the metric music of the world has no composer. Most music is simply passed down. It's improvised or passed down in oral tradition. So who gets to decide there who gets the beat? Well, we might all agree as a community that the quarter note gets the beat, but in fact, we don't agree. It's going to be a little hard for you to read, so but what that quote says is that the choice of beat vary widely between subjects and within individual musical excerpts. So here we have a fourth problem, which is that the definition claims there is a single primary level. We might ask, well, what is the difference between a strong beat and a weak beat? Strength is not a measurable attribute of sound. What does it mean to have a strong sound as opposed to a weak sound? Strength is clearly some kind of metaphor. It's doing some metaphorical work. So if you ask most musicians, they'll say, well, a strong beat is a little bit louder than a weak beat. And that's sometimes true, but it's not true in the general case, right? If you read an oscilloscope readout, there are plenty of pieces where the strong beats and the weak beats have the same degree of amplitude. Moreover, the beat is not a sound to begin with, right? The beat is a temporal address, right? It's a place where beats might happen. And so what does it mean that those temporal addresses are strong or weak? The only viable position is that strong and weak are sensations in us, or qualia. We sense them, but they have no substantial presence in the world. To invoke a Cartesian distinction, they are res cogitans rather than res facta. Yet the definition implies that strong and weak are substantive and measurable qualities. If for no other reason that they don't say otherwise, right? 6. Why are there only 2 different kinds of beats? This is I think, the strangest one from my point of view. So again, those are quarter notes in a 4/4 measure. So we would all agree that that's a strong beat. And at least for musicians who read music, and that those are weak beats. But which one is that? Is that a strong beat or a weak beat? Well, it's stronger than that, and it's weaker than that. So clearly the idea that there are only 2 gradations of beat strength makes no sense, all right? And that's true, especially say in the 12/8 meter, where there are 4 different ranks. So the definition suggests that beats are categorized binarily, but we experience them as gradated. So it's wrong what the definition tells us. Finally, why do the textbooks claim that there are 3 simple meters? In medieval theory, there were only 2 at a given level. A duration was either perfect or imperfect. It was either duple or triple. 4 is a composite number. It's not a prime. 4-to-1 proportion was perceived in medieval times as 2 duple meters, 1 slow and 1 fast. René Descartes in 1618 argued that there were 2 types of mensuration used in music: division into 3 or into 2. And explanations of the distinction between duple and quadruple meter as herd categories rather than notated ones are awkward and unconvincing. If I play you a piece and ask you, is this 1 measure of 4/4 or 2 measures of 2/4? And you weren't watching the conductor and you weren't looking at the score, it wouldn't be fair if you got it wrong for me to penalize you. In the same way as it wouldn't be fair for me to penalize you if I asked you, is this script that I'm reading from in Times New Roman or is it in Hellenic? What the classification system classifies is not meters, it's notations. Okay, so where did these come from? With the classification system, it's an easy one. It was initially proposed no later than 1694 by the musical servant of the Duchesse de Guise, a Frenchman named Étienne Loulier. During the first half of the 18th century, theorists disputed with each other about whether quadruple meter is collapsible to duple meter or whether it's its own thing. And this dispute went on for about 50 years. And by the time of Mozart and Haydn, it had been settled that there is a quadruple meter that's separate from a duple meter. The definition is a little more complicated, and I don't have time to go deeply into this, but I'll just show you one quote. Oops, there we go. This is from Kirnberger, a German theorist from around 1770. He writes, if one hears a series of equal beats that are repeated one after the other with an equal space of time in between them like this, then in our minds, we immediately divide them metrically by arranging them in segments, each containing an equal number of beats. And we place an accent on the first beat of each segment, or believe that we hear it as stronger than the other beats. And then we divide those beats into either 2, 3, or 4. We do not arrive at any other distinction in a natural way. So here we have beats, and here we have grouping or arranging in groups. And here that didn't quite work, but we have accents, and then we have groupings by 2s, 3s, and 4s. So perhaps most limiting is that, again, we have a single level of meter in Kierenberg's conception. There's a book by Danuta Mirka from 2009, which explains in great detail what 18th century German theorists say about meter. And they refuse to consider the idea that multiple measures can form a meter. So the idea of strong measures and weak measures, they reject that. They also say that the relationship between a quarter note and an eighth note, assuming the quarter note gets the beat, is not metric. It's external to meter. The meter is only the relationship between the downbeat and the counting beat. So part 3. We don't need this. Oh, don't need that either. Okay, here we go. Now we're back to ancient Greece. Ready? It's a long way to go. So Greek metric poetry has 3 levels of temporal regularity. So there's the verse flow, made of a fixed number of syllables, here 3, and a fixed rotation of long and short beats. Here it would be short, short, long, short, short, long. Notice it's not weak, weak, strong. It's short, short, long. And the Greek theorists say that the long syllable is twice as long as the short syllable. They all agree on this. So there's the verse foot, which is composed of syllables. There is the verse line, which is composed of verse feet. And that also is regular. Here we have tetrameter. There are 4 feet in each line. And then there's the level of the verse. And there's a fixed number also of lines per verse. So we have 3 syllables per foot, an anapest. 4 feet per line of tetrameter, and in this case, 4 lines per verse. Only the first of these is metered. Right? So there are multiple degrees of regularity, but only the relation of the syllables to feet fits the Greek conception of poetic meter. The other levels are regular. They're just not handled under the category of meter. So already we can see some parallels with the modern textbook account of meter. So what I'm going to do here is go through my categories and just make some simple substitutions. Syllables are grouped into a regular repeating pattern of long or short. This pattern is the meter. Syllables have acoustic substance as sounds. Syllables group together to form beat. Syllables occupy spans with measurable duration, long or short. There's a single primary level of syllable presentation rather than beat presentation. Long and short are measurable quantities. The long is twice as long as the short, at least notionally. There are 2 kinds of beats, long and short. And oops, that got covered over. But that says that there are either 2, 3, or 4 syllables per foot. Okay.
Sorry. Oh, it's good.
Part 4. And what I'm going to be talking about here is not my own research. This is just sort of settled history among poetic theorists. And I'm not going to go very far into it. As modern languages evolved around the 4th century, is what I understand. So it's the early Christian era. The metric distinction between long and short became merged with a rhythmic distinction between high-pitched and low-pitched sounds and louder and softer sounds. And so accent, I'm not sure that that's the term that's used, but that quality, let's say, becomes an emergent quality rather than a measurable one. So the distinction between longs and shorts stops being relevant to modern languages. And yet, as the theory of poetry is passed down through the ages and picked up by the Lutheran Reformation, the distinction between longs and shorts remained. And so if you were a schoolboy, not a girl, you would learn, you'd probably spend multiple years marking up Greek poems with macrons and brevs, and then doing the same for modern poetry. A historian of poetic meter, T.F. Brogan, wrote that the authority and prestige of classical languages ensured that the notions of longs and shorts was retained in Western metrical theory down to the 19th century, even though the actual linguistic phenomenon of phonemic length disappeared from Latin around the 4th century. And the main story to be told is simply one of wholesale appropriation of the categories and terms of classical prosody overlaid onto all subsequent Western verse systems. I should back up a little bit and say I've given this talk, and some people have said that's kind of reductive. It's not quite like he says, and so on. But certainly a trend. Okay, so now to part 5, which is the main part of my talk. Starting around 1500. Oh, again, I should get out of this. Starting around 1500, interest in the cultural products of antiquity surged, especially in Northern Europe. Initially in the humanist movement, which was centered around Erasmus, the Dutch philosopher. It also had its effects. Those of you who are music historians will know that there was passionate interest in the products of antiquity in Italy as well, in the formation of Florentine opera. Compulsory education was instituted as in the Lutheran Reformation, so we're talking later 16th century, which led to the formation of Latin schools, classical schools, where applying the principles of metric scansion was a multi-year project for schoolboys. So the prestige and readiness to hand of Greek and Latin poetics made it a natural model for a theory of musical meter. So why do you need a new theory of musical meter in the 1600s? The notational system is under great transition. So the prior model of musical time was linked to a notational system that had become obsolete. Durational symbols did not fully determine durations. If you had a particular shape, it was either 2 beats or 3 beats long. And if you were a singer who wanted to keep time, you better know whether it was 2 or 3 beats long. In order to figure out whether that symbol was 2 or 3 beats long, you had to be keeping track of several different pulses all at once. There are no bar lines to sort of limit the cognitive scope. And so you would have sometimes to think well ahead in order to make things measure up and therefore to be able to keep time. The new system that arose in the 16th and 17th century, bar lines and determinate durations. So this all was meant for 4/4 beats. So the singer has a much easier job, or the performing musician. They can keep their attention focused on counting 1 by 2 by 3 by 4, within the confines of the notated measure. And so it's not as important to keep track of so many different levels of unfolding time. For musicians, poetry was a vocational concern as well as a scholastic one. Most musicians were church musicians. Many of them, of course, also were theater musicians. In either case, the music that they created was sung music that unfolded around words. Text setting produces a fusion of poetry and music, a fusion as in pulling together into one thing. And it would have been very hard if you work with vocal music to cognitively separate the music part from the language part. They really are together. To the extent that composers and theorists of vocal music were able to think about musical meter independently of poetic meter, it would have been natural to assume that the terms and the concepts were mapping bijectively from one to the other. So poetic meter's at hand, and poetry is wound in with music. So this is not to suggest that musicians sort of mindlessly forced poetic meter onto musical meter. That would be doing them an injustice. But it's rather to suggest that the familiarity and the prestige of poetic theory, together with the artisanal pragmatics of fitting poetry to music, created a conceptual framework and just a way of thinking, a habit of mind from which it was difficult to detach. Music theorists began to compare poetic and musical meter in the late 16th century. The first, to my knowledge, was a blind Spanish cleric named Francisco Salinas in 1577. In the 17th century, Jesuit theorists in France and also in Italy became really interested in the relation between poetic meter and musical meter and started thinking about mapping them. So this musical meter is an iamb, this one is an anapest, this one is a trochee, and so forth. In the 17th century, and already in the early 18th century, you have concordances. So here's a list of poetic meters on the left and a list of musical figures that fit that poetic meter. This one happens to be from 1729. So to summarize this part of my talk, the hypothesis that the new theory of musical meter is rooted in classical poetics is consistent with the status of ancient Greece and Rome, the site of classicism, the appropriation of classical poetics, the position of those poetics in the schoolhouse, and the many attempts by early modern composers to map poetry onto music. So what could go wrong? Friedrich Marburg, who is an 18th century German theorist, wrote that the measure in music is what a foot is to poetry. Just as every foot has more than one syllable, every measure consists of more than one part. Marburg identifies one aspect of what seems to be a natural mapping from poetry to music, the central components of which are, number one, the verse foot concatenates, well, chains together between 2 and 4 syllables. The measure chains together between 2 and 4 beats. Syllables are binarily classified. They're either long or short. Beats are binarily classified as either strong or weak. They would have used different terms such as good and beats and bad beats. Verse feet are ordered sets of binary syllable classes, longs and shorts. Measures are ordered sets of binary beat classes, strongs and weaks. Poetry is metric if it consists of a succession of verse feet, which are all of the same class. Music is metric if it consists of a succession of measures, which are all of the same class. Okay. So the mapping proceeds very easily so far. But it also means that there are certain aspects of our musical experience that are left behind. There are also incompatibilities. And these were things that there was no way that music theorists were able to find their way around. So one incompatibility is that beats are more abstract than syllables. One recent theorist, Graham Boone, writes that the beat is silent, passive, utterly lacking in emphasis, not a mark, but a trace. Anirudh Patel, a linguistic theorist, writes that linguistic metrical grids are not abstract periodic mental patterns like musical ones, but they're simply patterns of heard prominences. The most difficult problem that faced 18th century theorists was determining the relationship between particular poetic meters and particular musical meters. So in poetry, you have a kind of combinatorial free-for-all. So you have longs and shorts, and they are either 2, 3, or 4 syllables, so that presents some constraints, but within each of those cardinalities, any string of short and long syllables is fine. So Augustine lists out these 28 meters as the possible meters. Each one has a name. In music, if we substitute strong for long and short for weak, we get impossible combinations from a musical standpoint. So we cannot have 2 strong weaks in a row. Our mind will automatically process one of them as stronger through a process called subjective metricization. This is also true if the strong beats are at the beginning and the end, then they cycle back and they become consecutive. And we also can't have measures with only weak beats. So we can throw most of those meters out. They have no use in music, and what we're left with is these. Okay? So now there's still another problem that comes up, which is that Markborg said that the verse foot is equivalent to the measure. But some of these are not measures. So these are measures. Strong and weak is a measure, strong, weak, weak, and so forth. So those 4 are measures. But what about the location of the other strong beats? They're in the middle of the verse foot. And so, right? And so what happens is that these verse feet, translated into music, are sort of overlapping the bar line. So we have the measure on the one hand, and then we have the group of notes or phrase on the other hand. And so we have this distinction between phrases and measures in music, which is collapsed in poetry. They're the same thing. The verse foot is the verse foot in poetry. That's a very awkward situation. Okay, I'm going to wrap up here. I'm very patient. So as I said, it would be unfair to say that 18th century theorists of musical meter mindlessly forced the classical poetic meter onto music. In many cases, the properties of poetry and music, which is to say the properties of our mental apparatus for processing language and musical sound, quite different. And theorists of music adapted, or sometimes they went in a different direction entirely. But in some cases, the properties of poetry and music are close enough that habits of mind take command and channel music theorists down a particular road, which leads them into a distortion of musical meter. And I'll just name 4. And this is kind of a review. Number 1, musicians. It makes more, right. To musicians, yes. For example, medieval musicians, it makes more sense to say that there are 2 kinds of musical meter at a particular level. Either we have duple or triple. Poetic theory encouraged musicians to open up a new category of quadruple meter. That's my hypothesis. The second one is that music induces metrical levels of temporal regularity, some slower and some faster. So we have meter consists of the whole notes, the half notes, quarter notes, and the eighth notes, and so forth. The theory of Greek meter focused exclusively on one relation between syllables, right? There were other regularities, but they were external to meter. And my hypothesis is that German theorists, out of a habit of mind, or maybe an overt respect for classical authority, channeled the many-leveled musical meter tree of medieval music down into one level between the measure and the counting beat. Third, the poetic syllable is a sounding substance with measurable properties. This encourages music theorists to reify the beat as sound and to misattribute it to its properties, such as duration, pitch, and loudness. And finally, and this is, I think, the most important one, music has many degrees of beat strength. It just seems to be the way our mind works. Greek poetics only recognizes 2 degrees, not of strength, but of length. And so music theorists followed suit by adopting a binary classification system. Beats were either strong or weak. And this badly falsified everyday musical experience. And 18th century theorists were forced to do a lot of hand waving about why, for example, the eighth notes weren't beats, right, and weren't part of meter. And that hand waving, I think, continues in the modern textbook. And so I just, to summarize, I realize that I've gone into some greater length to expose certain parts of my argument and left others more wide open. In some cases, it's because I didn't want to take too much of your time. In other cases, I haven't done the research yet. I really don't understand, for example, how what happened between 1800 and the current time. What happened to the theories of musical meter? How was musical meter taught in the interim? How did it happen that textbooks picked up on 18th century musical meter ideas? Okay, thank you very much for listening.
Well, thank you so much, Rick, for this intellectual ride. And we'll have some time for debate and questions. Maybe I'll start off with one. Please. It's interesting that you're talking about the juncture between theory or the discourses about meter and the experience of meter. And you didn't talk so much about the actual experience. And it just seems to me that, and of course, you did very well in saying, of course, there's this notative tradition. What about all this other music that is not notated? And yet people manifest in very explicit ways with their bodies how meter works. So I'd like to bring the body into the discussion. And also maybe in culture as well, and maybe in connection with that Kernberg example that you showed, that you have a series of beats that we naturally organize it into 2, 3, or 4, and then it just reminds me, or just if we ask that to some cultures, they would not at all choose 2, 3, and 4, maybe 7, 8, or whatever, right? Different. Which means that so it's interesting that one way of looking at this is to say that it is the input, the musical input, that is going to give you, or the properties of the music that's going to give you what is the meter. The other point is, how is that meter embedded in culture that will shape the way you are going to filter it? So that's kind of a part of the equation of how is experience and the uses of body come into play. But it also reminds me of maybe a kind of a follow-up, if you can talk to this, because you're talking about gradings of beats, right? Strongs and beats. I mean, somewhere in between. It just reminds me, again, touching with the notion of the body and the experience of the body. If we think about the diverse ways in which we use the body, which is not in 2 dimensions, but it's in 3 dimensions, right? I mean, if you look at conductors, looking there at Andre, they don't only do this, right? They move that, and if you dance too, you use the 3 dimensions. And so the qualities of the beats, it just seems to be that they actually use a spatial quality that goes beyond just 2 dimensions. And so just wondering if you could talk a little bit more towards the experience of the meter and how does that.
I thought more about the first part of your question than the second.
Okay.
It's I won't say it's a great question because there are 3 or 4 questions loaded into it. They're all great questions. What you're suggesting is that my argument has simplified some things, and yes, it has. So let me now confess some of the ways that my argument has simplified. If you are a classical musician or a musician who makes your music from notation, then part of your sensory input that is coming at you before you produce the music is notational, and it is visual. And certainly that shapes the way that you think about the music that you are about to make, right? And that in turn comes back around to shape the way that you are hearing that music that you are making. So it's true that it's a hermeneutic circle, right? Between the score and the sound. It's not just a one-way street. The other part of embodiment that I thought of, because I know you're a violinist or you used to be anyway, is that different instruments players have different bodily experiences. And even if you're a fiddler, a violin player, and you're improvising, you're not playing from notated sound, you're still going to be focused on one particular rhythm if your down bowing and up bowing is somewhat isochronous, right? You're probably, because those are the points at which your bow change, you're probably going to be focused to a certain degree on that, in a way that, for example, a trumpet player might not be. The trumpet player being more stationary and just wiggling their fingers and making tiny gestures with their lips and their tongue. I'm a pianist. I've never really played another instrument. And as a pianist, there's nothing equivalent to what a violinist does. So I'm playing a difficult passage of music. It's coming at me very fast. And I'm thinking at the same time of putting my fingers where they go in any given moment, but also I'm thinking way ahead and trying to get through the phrase, trying to hold it all together and pray that my body is able to keep it together, right? And so I think my experience there is quite different from a violinist's, and I think actually that, now that you've got me talking about it, that probably would benefit from a lot more thought. Were there aspects that I didn't address just now?
That's good. Are there questions in the room? I think we have one question over there. Yeah, no, please.
I know very little about classical poetry, but I have this impression that a meter is made of long and short syllables, like you said, but there are also stress patterns. Like if you take the beginning of the Aine, arma virumque cano, you have 2 dactyls and 1 spondylus, if I remember correctly, like tan, 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 tan.
You remember exactly.
Arma virumque cano.
Exactly. Yeah.
But the stress patterns in the syllabus, they don't match, because you don't say virumque, you say virumque. So I think I'm thinking that maybe there's a kind of polyrhythm, like you have a meter which is made of long and short, and you organize the feet according to the long. The long syllable is strong in this sense, but you also have strong and weak syllables according to stress, and they don't match, and this makes a kind of polyrhythm that makes the poetry flow in a more interesting way, compelling way. Do you think this has some kind of consequence in the musical thoughts?
In the music of Bach.
In the musical thoughts, in the way music theory has developed.
Oh, okay. Yeah. So you're right in everything you said. As far as I understand classical poetry, we have the rhythm of the arsis and thesis, which is, we think, pitch variation, which is patterned and which is essentially independent or orthogonal to the rhythms of long and short. I read I was educated on this by a recent article by a woman named Tosca Lynch, which is just an article on classical metrics. My sense is that whole aspect of poetic theory got pushed aside. And it's partly that is in the early modern period. So if you were a schoolboy, you didn't learn about that. And partly it's because there's no sort of standard way of notating the arsis and the thesis. When you notate, what you are notating is the longs and the shorts, okay? In the 18th century, and here I've only read a tiny bit, and if any of you are scholars of 18th century literature, I'd love to hear you speak about this. My sense is that theories, at least in English, theorists of English poetry began to explore the variation in, the arsis and thesis, and how that counterpointed the pattern of longs and shorts. And this happens at the same time when, in music theory, theorists and musicians stopped talking about long and short beats and started talking about strong and weak beats, or arsis and thesis. So there is something to be said here about what happens in the 18th century. I don't fully understand it. But I think for the earlier time, 16th and 17th, I don't think there's much awareness of what you were just speaking of.
Right.
Thank you. Thank you for your talk. Very inspirational. So I'm wondering if I can make a link about what you said your last conclusion about the multiplicity of rhythmic perception, what Tom said in this question. Taking an example of something that you know very well, the Steve Reich.
Steve Reich, yeah.
Okay. Let me see if I can make a good question. So my point is that, would we agree what is maintained in Steve Reich music is beat or not? That's the first question. The second one, if you say the beat is maintained in Steve Reich, what make us to feel different subdivisions?
Yeah, good. Okay.
So it's somehow in going conclusion, that means if Steve Reich has been thought about music in Western culture, instead of having been Ghana, when he has the opportunity to see how people before playing music, they use their body. So that maybe when he represents phase shift in his music, he's starting not to represent one of that experience, but one possible way of representing the experience he has sought there.
Okay.
So in that sense, maybe the musical meter that we're using in Western music is one of the possible representation of the phenomenon that we have done what we do in our culture when we do music. And maybe that's the reason that we have this discussion about what meter is, because maybe meter as is fixed in music theory is a representation of a larger gestalt of music is represented.
Absolutely, yes. Meter is not the only way to structure musical time. Right? And there's plenty of music in many different musical traditions, which is not metric, or where our metric sensibilities get frustrated, or which sort of goes in and out of being metric. I'm thinking, for example, of Middle Eastern, Iraqi oud music, which picks up a meter and then it sort of floats for a little while. So I don't mean to be saying that all music is metric. About Steve Reich. Okay, so I think that there are two different questions or two different issues, and I'll try to take them one.
I have a problem with that. It's a question for me. That's I'll ask you.
So let's leave the phase shifting to the side, because that's much more complicated. Okay, and of course, Steve Reich lost interest in phase shifting. Most of it, if you listen to Steve Reich's music, only a very small minority of it involves phase shifting. So let's leave that to the side. So how would I model the typical Steve Reich piece? I think in the same way that I would model African dance drumming, West African in particular, who's very influenced by. So typically a Reich piece will be in 12 beats. He goes in 12-beat cycles. Typically, at least if it's a faster movement, there is an isochronous pulse that's quite fast moving, right? And yes, that I do think of that as a beat. I do not think of it as the. It's a beat.
We have a fuzzy perception of people.
No, I just think that I think it's not a fuzzy beat. I think that we are tracking more than one beat at a time, and so there's no reason why we have to decide that this level of regularity is the beat, and this is not.
Our brain does it. Our brain shifts. When we see a kind of, for example, gestalt zone. Sometimes we go for one beat, and sometimes we go for another.
Shift attention.
Shift attention.
But in terms of what's accessible to us at a given moment, theoretically, there are many different beats. Steve Reich's music tends to be regular at a very fast level. Let's say the 16th note. Let's say the 16th note. It tends to be very regular at the slow level of the cycle. So there's a moment where you say the cycle's completed and I'm starting a new one, completed and I'm starting a new one, right? Because that's the rhythm of the repetition, right? And that's what's most like the African dance drumming, the bell pattern. So you have a beat that's very fast and a beat that's very slow, and the ratio is 12:1, right? Okay, so what happens in the middle? Well, a few different things. You can have 12 and 6 and 3 and 1, or 12 and 6 and 2 and 1, or 12 and 4 and 2 and 1. Those are all symmetric divisions, and they're all meters. And Reich moves between those, as does a good African master drummer. Moves between those three. So I would say that at a given moment in Reich's music, there are 4 different levels of regularity. But the levels in the middle are susceptible to metric modulation. And that's what gives the music its dynamic properties. Now, back to phase shifting. Phase shifting occurs in continuous time, right? Continuous time cannot be notated. Western notation is conditioned for the notation of discrete time, right? And actually most notational systems are, because continuous is very difficult to notate because there are an infinite number of points between any 2 points, right? So I don't know how to theorize, even though I've written about Steve Reich's phase shifting process, I don't know how to theorize the phase shifting. I don't know how, using my understanding of musical temporality and the tools that I have, I don't have a way of telling you what is going on in the phase shifting process. If you do, I'd love to read about it. It's hard.
I read your article. It's curious to have this question very actually.
Are there more questions in the room? Ron?
Thanks, Richard.
Yes, I have.
Let's say you sort of get hurt my ideas of listening to music while I'm driving my car, which is always very afraid of listening to and music theorists. I don't want to my interest, because I don't understand a thing about music.
He's a biologist.
Exactly. And but my question is more related to sort of the origins of music, its connection to language, and sort of how that plays or played a role in the history of our species. And so you talk a lot about trying to connect music to poetry using the Western sort of classical music. So you have poetry, I would say, is a very specific type of language, and oral communication is also a very specific type of language, right? Because again, we talked about body movements and how that's a type of language. So my question is, it's not even a question. I don't know. It's a question. It's a lot of disorganized thoughts. Can we trace parallels between sort of the evolution of language in all its forms and the evolution of music, and which comes first? I guess that's sort of what goes in my mind when you compare Western classical music to other cultures. Right?
Yeah, so this is a question that has arisen at a lot of different times. Rousseau in the 18th century was very interested in this. I don't know much about it. If you're interested in the sort of ancient evolution, I have a book to recommend to you, which is by Gary Tomlinson. He deals with that question in great detail and concludes that the relationship between our evolutionary, our very old capacities for music and our very old capacities for language is overdrawn. It's a very complex book. It's a complex thinker. So I don't dare to summarize beyond that. In the history of Western music theory, music theorists talk about language all the time. Why? Well, we can't talk about music on its own terms, right? So we have to borrow language from somewhere, and music and language share many properties. They unfold in time, right? And in sound. And so, in every century, there are music theorists who talk in some way about music and language. Some of them talk about grammar, excuse me. Some of them talk about grammar, some of them talk about, the letters of music. Some of them talk about the meaning, the semantics of music. Some of them, map phonological properties of language onto music, and so forth. It's just been an ongoing project. Some of them talk about musical rhetoric. Big in this thing in the 17th century, musical rhetoric. But it's sort of a natural way for musicians to look. And it's exciting, and then it falls apart. Because music and language are not the same thing. So, is that helpful?
Yeah, I guess I think I got your opinion on music and language.
Tomlinson, Tomlinson. He's written 3 books on evolution and music. It's the first one you should read. Well, I haven't read the other 2, so maybe.
Okay. So one more question here. Oh, there. So, sorry, but we're
Yes,
privileging
we have-
people here. So yeah. Go ahead.
Well, I don't know if mine is a question or not, but it's a thought I had during your presentation. I study math. Okay. So
Used to be,
Heavy metal.
Heavy metal.
oh, right.
There's a particular band that is very interesting in terms of meter. There is Meshuggah. I don't know if you know that yet. Okay, so it's not kind of a question, but it is an observation. Well, their music is really complex, multi-level music. The polymeter, guitars are one dimension, the drums another one. There are some articles published that are notated and that make patterns of 4, 3, like you mentioned. And it's a very complex music in terms of rhythm and beat and meter. I give some lectures on for teacher. And lately, during one session, I was presenting the music of Meshuggah, and when they play live, they keep a bit they keep a pulse. Their body movement.
Oh, their body movement. Okay.
It's regular, or sometimes it's unbalanced, but it's very interesting to watch them live because the experience from the crowd is always trying to have a regular beat, but the musicians are not actually keeping that beat, so it's a very different experience.
Mhm.
So the drummer, the bass player, the guitar, they do this awkward movement, sometimes according to the music, sometimes not.
But they're synchronized with each other.
Yeah, they are synchronized. And this time, one of the teachers I was lecturing to asked me a very interesting question. He asked me, look, he asked, does the singer also play the guitar? And that's really striking because the singer is not singing, it's guttural singing, so it's screaming, okay? But he has to keep time and track of time. So it's a very multi-level, and that made me think, what if the singer really plays the guitar? Would he be able to perform that two levels of complexity, the meter, the poetic rhythm, the words, and the extremely complex music in terms of rhythm? Well, the lead singer does play the guitar, but he does not play during their music. Right. So he never performs singing or screaming and playing the guitar, all that complex music. So is there a limit? What is this interesting for this talk? Maybe if there's a limit in the performative dimension of this multi-level, if we really come down to the base that we need to simplify, for instance, and to sum up, when my composition students want to write asymmetrical music, I always tell them, okay, look, you write asymmetrical, but the musician, the performer, will always, or mostly, will try to figure it out in models of 2 or 3. I never mentioned 4. I always mention 2 or 3 because I'm aware of the rhythm. So this is just an observation if you want to.
There's so many fascinating things in there. I'm really curious to hear more about your research. So there are a few different things. But I don't know if I have anything interesting to say about any of them, but let me give it a try. So as the music of Meshuggah that I'm aware of, the cycles are all different from each other, but they're also very long cycles, and they tend not to be composites of 2 and 3, right? So the cycles are maybe 17, they're very long prime cycle, 17, or maybe they're composite, but not 12, more let's say 14 or 25, right? And it's very hard to hear those long cycles as stimulating a consistent interior faster pulse, right? So you end up concatenating two, here's a 3 and then a 3 and then a 2 and a 3. So it's a different way of thinking about what pulse is. It's much more irregular, right? So, there's a fastest beat as in the right. There's a slow cycle of say 14 or 25. What happens in the middle is not regular, okay? As far as the singer goes, who knows? It would be nice to interview the singer, but there is one hypothesis about listening to music, or for that matter, listening to speech, which is that we are moving our bodies in a way that's imperceptible as we focus. That when we focus on music and we're trying to move with it, to absorb it in some way, there's some part of our body that is moving with the music. You just can't see it. Maybe it's what people call mirror neurons, which I'm afraid I don't know anything about. It's just a buzzword for me. But Arnie Cox has written about this. There's a book by Arnie Cox, COX. So now, if you are a player of a particular instrument, part of the way that your body is, when I listen to music and I'm very absorbed, I'm kind of playing the piano, drumming that note, down to that note, right? And if you watch my fingers, you might see them twitching a little bit. So we do tend to hear through our bodily experience. And if the singer plays guitar, it might well be that he is twitching like this, right? As that would be a hypothesis worth exploring in any case.
Okay. Go ahead.
I'm very interested in the experience of music and performance. So going back to the beginning of the lecture, you were talking about the inborn capacities of music, and that's something I'm very interested about because there was no data on it, and I'm very interested to learn more about it. And then you moved to talk about the 18th century poetry and beats in terms of measurements. And to me, they're almost opposed because it's like you try to build up a system in something that is inborn. So it's going against the experience. It limits the experience of hearing music somehow. So, this is coming from a person who don't, I did not study music. So this is something that I was, as I was hearing you, I was thinking, because you were talking about the beat being strong and weak. And somehow it seems to me that you were also talking about moral properties. Moral properties.
As in ethical.
Yes.
Oh, interesting.
Well, yeah, could it be related somehow? So it's in a way to control the experience of the body. You go into good or bad, or to become strong. This I don't know. It's coming to me, and it's something I want to ask you if you have thought about this. If something that you came across.
Okay, so I think you're asking two different questions, and I'll try to take them one at a time. The first question pertained to, if I can paraphrase back to what you were hypothesizing, is that if music, the capacity for music is born into us, then isn't a particular way of constructing the music, is that going to be then conflicting with our inborn capacity? And I think, well, I haven't thought a lot about this
It's more than that. It's like, it's building up a control system for then the body. Doesn't
Right.
go beyond his full experience of pleasure. Or
Yeah,
it's even, it's more than contradict the inborn fact of it. Is it by measuring it, you build a control system or controlled apparatus to limit the experience of something that can be quite powerful and that could give you an extreme of pleasure.
So I guess I would point to experiments by Laurel Trainer, a Canadian music psychologist, and Jessica Phillips Silver, another Canadian music psychologist, where they do experiments with newborn infants who have not been distorted by culture. Okay?
Yes.
Well, who knows? Maybe they're listening to music in utero, but it's as close as we can get. And for example, they have them, they play, for example, metric music, and they have the parent bouncing them on their laps at a certain pace. And when the bouncing is synchronized with the music, the kids are happy. And when it's asynchronized, the kids they register disturbance in whatever way neonatal infants register disturbance that psychologists read. So that suggests that the amount of sensibility for musical time that we are born into is very controlled. It's controlled by our neuronal system. And that if we want to make music that doesn't have that control, that is, chaotic rhythmically or very free of the beat, we have to work pretty hard in order to free ourselves from the control. So it's not that we're born free and the control grabs us. It's that we're born to recognize simple patterns, and we have to work hard to break out of that. Now, as far as the ethical part of what you bring out, I don't tend to think about any of this in those terms, so I don't think I have a good answer for you, but I'd like to hear more from you sometime about what is it in what I said that sort of pointed you that I was maybe quietly thinking in that direction.
Maybe we can listen to a question from Zoom. We have a hand reason by Felipe Marques Rocha, and then another Lidwino. Let's start with Felipe. Go ahead, please.
Thank you. Thank you for your lecture, Professor Cohn. My question is about the last slides, about the combination.
Well, there's some distortion there.
Yeah.
It's possible to hear me? Hello, hi. It's possible to hear me? Sorry, I can't hear you. Hi, hello, testing. It's possible to hear me now?
Yeah, but it's just that if I do it, it does it.
Can I? Okay. Could you hear me now? It's possible. Thanks. So thank you, Professor Cohn, for your lecture. I am Felipe de Matos Rocha. I'm from Brazil. And my question is about the last slide of your presentation, when you show us the combination patterns of weak and strong combinations. I agree with your presentation, but I would like to hear more about your thoughts. Why only these ones combinations are useful for music? Because sometimes we need to explain why for example, strong, and weak, it's not possible. But sometimes we don't have so much arguments to explain that. So I'd like to hear more about that if you can share me your thoughts.
Okay, so the question then is, if we think about how in the 50s and 60s, the work on Leonard and Cooper has recovered the notion of poetic meter, and we brought it into the ways in which we theorize about it. And then later, we've jackened off and say, no, we have to separate these two domains, rhythm on one side, meter on the other side. And of course, Hasty comes and say, no, we have to put them back together. So how do you stand? Do you think rhythm and meter should be kept separate, as in that they indicate different realities or different modes of dealing with sound? Or is there a way that we should bring them back together?
I think as a good starting point, you should keep them separate, but because we have different models, different ways of modeling them, and it's easy if we wrap them together into one, it's easy for us to use the wrong model for the wrong phenomenon. In the same way, for example, so at a certain point, you want to bring them back, you want to see how they affect each other for certain. Grouping and meter are in this circle. How things group affect how we induce meter. And our induction of the meter in turn affects how we group. It's the same sort of problem we have with pitch and rhythm, right? So as music theorists, we have a theory of pitch, we have a theory of rhythm. We talk about pitch, say harmonic progressions independently. We talk about meter independently of pitch considerations, but at a certain point, we don't want to keep them separated. We want to bring them together. So, ideally, you would bring them together all the time, but keep in mind that you need to tease them apart, and where the points are that you need to tease them apart, where the pitfalls are, if you bring them together into one big soup.
Sounds good. Okay, very good.
Sobre o YouTube está a entrar novamente no computador. Tem que se silenciar no YouTube.
Agora sim, mas só.
Então, agora vamos dar então voz ao aqui, não é?
Sim.
Filipe, vamos retomar. Eu penso que talvez consigamos ouvir agora bem. Pode tentar outra vez de novo? Não sei se me está.
Okay. Thanks, Professor Cohn, for your lecture. I'm Felipe from Brazil, and I would like to know more about your thoughts in relation to the last slides in your presentation. You show us the patterns of strong and weaks, and some of these combinations are not useful for music. I agree with the results, and it's very known, yeah, the results, but sometimes we don't have so much arguments to explain that, and the solution is give axiomatic explanation. So I would like to know more about your thoughts in relation to why these patterns are not useful or the other are useful.
Yeah, that's a really good question. So one way of asking the question is, why can't we have two strong beats in a row, right? And the response that I would give is that we seem to, and there's good evidence of this, have this capacity for what's called subjective metricization, where if we are listening to isochronous equitonal sequence, beep, 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 like that, that we tend to unequalize the individual time points. So we consider, say, the odd ones to be strong and the even ones to be weak, even though there's no evidence within the acoustic signal. Okay, this is what's called subjective metricization, and it's very well documented from different experimental protocols. Okay, so the first answer I would give is that we can't have two strong beats in a row because our subjective metricization faculties will not allow us. Now, the second part of it is that there are certainly situations where, for example, let's say we're in 3/4 time and we're not sure which one the downbeat is, right? And it might be the notated first beat, and it might be the notated third beat, and we're divided, right? So in some sense, we're hearing the first beat as strong, and we're hearing the third beat as strong, and they're kind of in conflict with each other. So we want to know then, which one do I move my body? Do I tap on the first beat or do I tap on the third beat? Okay. And the way that I model it, I don't know if it's the only way to model it, is to say that there are actually two different meters that are present, and they're present in some equal way. And somehow the composer has managed to balance them with each other so that it's not that we are absorbing them both into one fused gestalt, but that we are not sure. Sometimes we hear this one is stronger, sometimes we hear that one is stronger, but it's a kind of a conflictive state rather than the fused state that we have when we are in a meter. So that's how I think about it. Having said that, there's music where one has a sense of bunch, 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 like that, right? Where there are events going on beats 1 and 3. And they're more or less the same intensity. But my sense is that one tends to favor the later of those. When you have two strong beats in a row, the later of those is the one that we subjectively metricize as more marked. I also think that's likely to vary by culture. It's not a universal. What is your sense?
Yeah, yes, I agree with that. We always choose one as a accent. Yeah. And for example, Cooper and Maya shows the only 5 patterns
Right.
among a lot of given by Matterson, for example. So sometimes it's explained by a cognitive perspective, but I'm thinking in these days about how explain it in a musical form. So it's important to hear you and think more about that. So thanks.
Well, thank you for the question. I really appreciate it.
Liduino, como vai? Tudo bem?
Tudo bem.
Quer fazer a pergunta?
Yeah, my question is the same question of Philippe, but I think I will do it again. So because I still keep the problem. So thanks, Dr. Cohn, for the wonderful lecture. This is Liduino from Brazil.
Hi, Liduino.
Hi, how are you?
Good, thank you.
And so Philippe asked about these 5 patterns that may, let's say, filtered from a large amount of possibilities. And Philippe and I were doing a doctoral work on that. And the question is, how do you explain what's the philosophical, logical, or psychological or cognitive basis to say, okay, it's impossible to have 2 strong beats or no strong beat musically it makes sense, but when you formally write about that, what would be I don't know if you have a thought about that, but what would be the argument for that, psychological or cognitive?
Yeah. So there's a long history of sort of anecdotal observations. Starting in the 18th century, there was a Scottish theorist named John Holden who had a pocket watch, and he listened to his pocket watch, and he understood that the escape mechanism was such that all of the ticks should have been the same strength. There's nothing physically different about the ticks. And yet he found that he was ascribing, he was thinking of one of the, well, let's say the odd number tick as stronger than the even number tick. In the late 19th century, when they finally got, were able to control electricity well enough to, design, to have a sort of equitonal beep, beep, beep that was exactly the same amount of time and exactly the same loudness and so forth. This guy called Thaddeus Bolton did a series of experiments, and he found that when we listen to an equitonal isochronous set of acoustic impulses, that sometimes we hear it in 2, and sometimes we hear it in 3, but we inevitably do one or the other. The most recent research is by, I think, is it French or Belgian researcher named Renaud Brochard, who's a neuroscientist. And so, he did what neuroscientists do, wire people up. And he did what's called I think it's an oddball design, where you're listening to some pattern and then you disrupt it. And he found that if someone's listening to an equitonal isochronous signal, that if you disrupt it on the odd number, that people are much more disturbed than if you disrupt it on the even number. So if I go 1, 2, 3, 4, 5, 6, right? If I disrupt there, then it's not as disturbing as if I do 1, 2, 3, 4, 5, 6. Right? More disturbing than if I disturb what would take to be the downbeat. So, I'd say that to my understanding, the research about this is pretty robust. And then, the overall, the general phenomenon is simply, it's referred to as subjective metricization.
Thank you.
Sure, I can actually go with those references.
Okay, yeah, I didn't get the French name that you just said, but the other one is Boltzmann, right? Thaddeus Boltzmann.
Yeah, that's it.
Yeah.
Yeah, I'm writing a book. One of my books finally finished and out in the world. Chapter 3 will be largely on this particular topic. So, but thanks for asking me. That's fascinating.
Thank you.
Thank you, Lidwina. So this starts to seem like the Haydn's farewell symphony. I think it sounds like we should wrap it up. So one round of applause again. Thank you. Muito obrigado a todos.